about advanced attacks on Bitcoin wallets and cold storage. So it's really a talk very closely related to the previous talk. There are many different methods to steal Bitcoins. Most of them you have never heard. I must tell you that following what's going on in the press and the media about Bitcoin, the information that you are given by major sources such as CoinDesk and other sources is incomplete, very frequently incorrect. So Bitcoin has become a vast topic nowadays. There are lots of possible attacks, and there is a tendency to misinform the public, especially by well-known Bitcoin evangelists, by well-known Bitcoin journalists. They don't tell you the truth. They don't tell you what they really think. And there is a tendency not to inform the public about the attacks until it is too late. So typically, we learn a lot of things about attacks after the money have been stolen, and not before. On my behalf, I would like to consider that we should warn the public before the Bitcoins are going to be stolen. Yeah. And this is what I'm going to do during this talk. Okay? I think this is done very insufficiently in the Bitcoin community to warn about threats and attacks. Okay? I'm a cryptologist, and actually there are good guys and bad guys in cryptology. I'm a code breaker, I break things, I'm the bad guy, no? I have been once accused by provoking an international crisis, cipher crisis, on the first page of New Scientist, a long time ago. More recently, 2013, our team has won the University Cipher Champion competition in the UK. I'm also a specialist of applied cryptography, smart cards and payment. And I have worked for 8 years for the French industry, which basically kind of pioneered the smart cards, bank cards, SIM cards, contactless cards, and so on. I also am a founding member of a group which is called Codebreakers at LinkedIn. So people who are interested in this topic of how you break things, please join our group. It's a selective group, by the way. Not everyone can be admitted, but we usually admit all good specialists. I also have a blog, and in London we run a Ucl Bitcoin Seminar, which runs more or less every week, which can be found on the same blog. Basically, just click on this button, Seminar, and you'll find the schedule for our seminars in London. So if you are in London, you can drop in at our seminar, invited. And please also have a look at my blog. It contains a lot of interesting information about Bitcoin, which are difficult to find elsewhere. Okay. So Bitcoin is a digital currency which is based on public key cryptography. The equivalent of a bank account is a pair of public and private ECDSA keys. And when you spend money, all you need to do is produce a digital signature. Wallet is like an application on your mobile phone. Okay, you have somebody's Bitcoin address, either as a string of characters or as a code to decode, and you can send and receive money just by knowing someone's address. We also call a wallet a file which stores your money. So basically, it essentially stores your private key. Okay, maybe encrypted by a password, but not always. Sometimes in clear text. Okay, and a Bitcoin app, like on a mobile phone, is also called a wallet. So Bitcoin works with blockchain. I will skip some things here because I think everybody knows how Bitcoin works. So just few remarks. So Bitcoin mining is about running a certain hash function in a loop. in which the inputs are the data from previous transactions, the miner's public key, and some random number, which is necessary to make it work. And then you hash and you obtain something which basically must start like with 67 zeros, maybe, something like this. Okay, maybe 66 zeros. Each time you do this, you produce a block. Okay, so Bitcoin blockchain is a sequence of blocks, which is also a ledger, and which also is a transaction database shared by anyone in Bitcoin. And every transaction since ever in Bitcoin is public in this ledger. So transactions have an interesting life cycle. So they are generated by wallet nodes, like in a previous stock. Okay, they will be sent to peer nodes. Okay, so currently there is few million wallet nodes in Bitcoin network, but only about 250,000 are really active. They have some Bitcoins, and they are really doing something. Okay, so they will send them to peer nodes. This is already a much smaller number because currently in the Bitcoin network there's only about 6,000 really active peer nodes which receive incoming connections. And then these peer nodes are going to send these transactions to other peer nodes, but what is very interesting, when they reach the miner nodes, people who are mining, and this is also actually a small number, and even though actually the number of miners is still very large in Bitcoin, maybe 50,000, maybe less, nobody knows exactly, miners concentrate their input points to the miner pools. So so these 50,000 miners, the transactions will reach them through an extremely small number of pools, which are going to aggregate the transactions for the miners, and which are going to tell the miners which blocks they should be mining and which transactions they should be mining. Okay, miners are in current Bitcoin totally deprived from the capacity to decide anything about Bitcoin. Pools have confiscated this power totally, and pools actually decide about everything about Bitcoin, and Bitcoin is currently very, very highly concentrated. So the pool managers effectively control the Bitcoin network at this moment. And it's a classical example of where people give out their power for free and without getting anything back. Okay, because in theory, Bitcoin miners could decide what's going on in the Bitcoin network, could say, okay, we don't agree with this spec, with this upgrade of the Bitcoin network, and so on. So in theory, Bitcoin miners could control the present and the future of the Bitcoin network. In practice, they have so far, in the recent years, totally relinquished this power to a very small group of people. Yes, to a cartel of Bitcoin mining pools. Yes.
So this is so that as soon as any mining pool operator starts to mess around with transaction and it will become public, that the mining pool is actually dead. From this economic incentive, there's no incentive to mess around.
No, because nobody will notice if they mess around with transactions.
So if my transaction is reversed because of the malicious mining.
Yeah. So if you attend talks by some people who are very, very good at monitoring what's in the blockchain, you will learn, for example, that currently some transactions are not approved for weeks in the Bitcoin network. Nobody quite understands why, and you will learn that many transactions reach just half of the peer network and nobody understands why either. And it's not, the situation is not neutral. The network neutrality in Bitcoin does not exist, and pool managers could potentially invalidate a lot of transactions, because currently in the Bitcoin network, some people use multi-sig transactions, which only exist because they are accepted by some pools. So if these excessively rare pools at this moment just stop mining these transactions, people will send money to nowhere and their bitcoins will be lost. Okay? So current situation is extremely fragile, and there is a total lack of network neutrality in Bitcoin. Yes?
Is this a new phenomenon in the sense that initially you just had these miners and this pool that you're talking about did not exist? There was a necessity of this intermediary pool, which you explained is effectively taking the initial control away from the miners. Is this a sort of newish phenomenon that has sort of developed over time?
Yes. Basically, on one day in 2013, a Stratum protocol was specified by a Czech developer, which everybody knows, this guy, Slash. And on this very day, when people have adopted this protocol, the control of which transactions go into Bitcoin network was shifted from miners to the pool managers, and somewhat irreversibly. Today it will be extremely hard to change because you would have to simultaneously convince the pool managers to change, and they will not change. Simultaneously convince all the manufacturers of ASIC hardware to change, and they will not change. And also everybody else. Okay? So there have been in Bitcoin network this irreversible power shift to the current situation due to the adoption of the Stratum protocol. Okay? And it's very hard now to change anything.
Do you have any thoughts about other commercial parties behind this who might have initiated this shift of power in order to get a more favorable position?
I don't know if it gives anybody a more favorable position. Maybe I wouldn't discuss it. Okay? So it's just a fact of life. The fact that actually Bitcoin protocol is not specified by Bitcoin Foundation, not by Bitcoin developers, not by Bitcoin software. Please do observe that Stratum protocol is a layer of the protocol which is totally outside of the spec of the Bitcoin protocol. Yet it makes such a huge difference in terms of making Bitcoin totally, the power of deciding which transactions go into the Bitcoin blockchain being so concentrated nowadays. Okay, so it's a very bizarre situation where Bitcoin, the control of Bitcoin has shifted away to some sort of ad hoc situation. We have a cartel of different large ASIC manufacturers, we have a cartel of different large pool managers. So, and basically, these people are comfortable with their situation. They are not going to switch to something else, unless they have to. But this is not very likely to happen anytime soon. Okay, so it's an interesting situation which we need to try to appreciate things how they are, and well, I don't know if it's really such a big business interest. These companies currently are near bankruptcy and they are losing a lot of money. So it's not like Big Telco or Apple or Microsoft with very powerful vested interest. It's a sort of ad hoc configuration which happened in Bitcoin community. Okay. So the miner nodes are going to collect these transactions. They are going to literally burn them into the blockchain, because obviously it's an energy-consuming process. It's really like burning a DVD. Each block is like a DVD which you have burned and you kind of release. Okay? And then it goes into the public ledger and is broadcast to everybody in the Bitcoin network in various ways. Okay? So this is the transaction life cycle. So a Bitcoin address, sort of equivalent of a bank account, typically, but not always, is a hash of a public key, to simplify. And only this is revealed, a hash of a public key. The public key is not revealed, which is extremely important. Okay? Public key can remain confidential for a very, very long time, until the last minute, when basically your money will be spent. Okay? So imagine that the NSA can break the Bitcoin curve, but your public key is not revealed. Well, they have to do it in 1 second. and then there will be a race condition in the NSA transaction they have posted to the network, and your own transaction, which have been released, because this is only at this moment when you release your public key. And even at least 50% of the time, the legitimate user will still win the race against the NSA. This assuming that they can break the curve in 1 second. Okay? So this is a tremendous protection against insecure and bad and insecure cryptography. Okay? This is a really, really brilliant thing that Satoshi did, specified in the Bitcoin spec and software. The fact that the public key is not revealed. This is really, really brilliant. Okay? However, people who benefit from this are only those who use Bitcoin in a certain way. So basically, they don't use the same account many times, and the public is not revealed. So there's a lot of people who don't use Bitcoin the correct way, and actually their public key is exposed, and their Bitcoins could be stolen more easily. Okay. So there are also multi-signature addresses in Bitcoin. So multi-signature addresses are formed essentially by a combination of several public keys. Okay, and you have something like 2 out of 3. Okay, so in order to spend the money which was sent to this address, you need to produce 2 signatures out of 3. Okay. So this leads to very interesting philosophical questions. Who has the money? Everybody has the money, nobody has the money. Can you seize the money, and so on. Okay. This is an extremely powerful technique. This is really, really strong. Okay, multi-sig is excessively strong, if correctly used. Okay?
Sorry, so does it use multiple private keys or multiple public keys?
Yes, it uses multiple private keys and multiple public keys.
Oh, okay.
Okay? And it's very powerful. For example, it really does solve the problem of insecure devices, insecure operating systems. Okay? Because, for example, you could have 5 different devices and make sure that you need 4 of them to spend your bitcoins. Okay, and it also solves the problems of backups. You basically sometimes just don't need a backup with this sort of multi-sig system. You lose one device, it's okay. You have the other devices. You transfer to a fresh account with 3 other devices, and so on. You just don't need the backup of the old device, the one that was lost. Just transfer them. Okay, so it's a very, very powerful technique. So it can be seen as adding another layer of security on the top of Bitcoin. Okay. So Bitcoin transfer in general is about a person running a client, a software client connected to the cloud or to the internet, and basically Bitcoins are going to be transferred to another client, basically. The new owner will be the person who has a certain private key or who has a certain subset of private keys out of another set of private keys. Okay? So Bitcoin transfer, the unit of transfer is a Bitcoin transaction which admits several inputs and several outputs, and the difference between inputs and outputs is the fee. Okay. Typical Bitcoin transactions must be signed by all owners with their private keys. Okay, so everybody has to approve them. If somebody does not approve them, the whole transaction will be invalid. Okay. Transactions in Bitcoin are processed through the concatenation of scripts. Okay, so basically the initial attribution of money, it always is written in the Bitcoin data as a script. And then if you want to spend it, you send something like another script to Bitcoin network. The concatenation of the two is executed. And basically it's like, in typical cases, the first script says, okay, well, you can spend this money if you can produce a digital signature for a transaction with a certain public key which hashes to this. And then you have the hash of the public key. Okay? And then your second script must be a valid digital signature plus a valid key which hashes to the right value. Okay, so that's a typical transaction, but there are more complicated ones. Okay, so if we look a little bit at this binary data in these transactions, okay, here are some real-life examples on this slide. In the transaction, you have the input and the output, and the input will contain basically input scripts, and the output will contain output scripts, which essentially are, for most transactions, just hashes of public keys with a little bit more data. Okay. So, as in previous talk, we are interested in the second script, the spending script. Okay, so the spending script, well, it contains an ECDSA signature. Okay, so the ECDSA signatures actually will be two numbers, R and S, which constitute the ECDSA signatures, which are here written in hex. Okay. So, interesting question is if Bitcoin is secure. So my job, like a cryptologist come breaker, would be to break the Bitcoin if I can. Okay. This is what I'm going to do today a little bit. Interestingly, Satoshi does claim in his paper that Bitcoin is secure and many times. It's quite interesting. Okay? But it's not like a very, very precise argument. Okay? It's extremely vague, and it's mostly about security, you know, against coalitions of attackers who have large computing power and so on. Okay? But in general, we can say something like Satoshi believed that Bitcoin was secure. He has written in forums things like, oh, I think SHA-256 is very robust hash function. Okay? Okay, he has clearly written things like that. Okay. So there's an interesting question. What is a secure cryptography in general? Okay. So for me, a secure crypto system is one which cannot be broken in less than exponential time. And this goes back to John Nash, which is a very famous US mathematician. In 1955, he wrote a letter to the NSA, which was recently declassified, and he says, well, a good crypto system is such that the computation length increases exponentially with the length of the key. So this is apparently the first time which this kind of principle was written by someone.